Hello, stat students. As requested, I'm going to go over number 25 it's the Cumulative Practice Test right after Chapter 7 and the Practice Statistics textbook. This is a difficult problem, so I'm going to walk it through and hopefully it'll help you guys out. In a city library, the mean number of pages in a novel is 525 with a standard deviation of 200. You will notice that I'm going to highlight the important stuff here. Mean number of pages, 525. Standard deviation of 200. Approximately 30% of the novels have fewer than 400 pages. Here's the big thing. We randomly select 50 novels from the library. Now we have two questions here. First question is, what's the probability that the total number of pages is fewer than 25,000, and they ask us to show our work. All right, here's the approach I would take. Now we know for a single book, you're looking at 525 pages. So you figure if you're going to be doing 50 books, all you have to do is do 525 times 50. And we're going to plug it in here, but I did it earlier. 50 times, 525. I get 26,250. So that tells me that's the number of pages I would expect. That's the average number of pages for 50 books. Now, of course, we know it's not always going to be that smooth, but what we'd expect is 26,250. Now for the standard deviation. This is where a lot of people tend to go wrong with this. Since we have a standard deviation for one book of 200 pages, right? A lot of people would just think, oh, we're just going to add 250 times to represent all 50 of those books. But you have to remember, when you're combining standard deviations, you have to go to the variance first. So here's what I would do. Couple approaches here. This is what I'm going to do. That 200, I'm going to square it. I'm going to add plus 200, I'm going to square it. I'm going to do this to represent 50 books. This represents one book, two books, three books. I can write this out 50 times. It's going to be crazy. It's going to be a lot of work. So the easier way to do this, instead of doing this 50 times, adding 200 squared, I'm just going to multiply it by 50. So remember, when you're combining standard deviations, you got to find the variance. And once I find that variance, I find the square root, and that gives me that standard deviation. So I'm going to do this out, and I've actually already done it out. So let's see. Hopefully you guys are following along. You can plug it into your calculator. I'm just going back a little bit here. All right. And you get 1,414.213, somewhere in that ballpark. So now we know the standard deviation. We know the mean for 50 books. Now we know the standard deviation for those 50 books. Now we know the distribution is going to be normal because they told us at the beginning here, let's see, a number of pages. They don't tell us that it's normal, but guess what? Since we have so many of these, it is a normal distribution here. Since we got so many books here, yeah, it's going to be normal. Let's see, a book, mean number of pages. Yep, there we go. So we're going to keep going with this. Now what I can do, this is what I advise to do, frankly. I draw a nice normal distribution here. And you know me, I always like to draw and label. 26,250. And then I'm going to keep it very basic. I'm just going to add 1,114 each time. And you notice I'm not even going to go up because I don't really care about going up. I'm trying to find probability that the total number of pages is fewer than 25,000. So I want to get to fewer than 25,000. Which if I go down one standard deviation, I get 24,836. So I know that 25,000 is going to be somewhere in here, right? It's going to probably fall here, and I'm looking for everything less than that. Now, based on what I know about the empirical rule, I know, this is going to be about 2.5% here. 13.5% here, and then this represents about 34%. So I know, looking at this, I should probably get an answer of, let's see, 2.5 plus 13.5 gives me about 16, plus a little chunk in here. I'm probably looking at about somewhere in like the low 20s. But how do I calculate it exactly? We're going to go norm CDF. I'm going to plug in negative infinity, because again, it can have, going all the way in this direction. The upper value I'm looking at is at 25,000. So again, I'm going to label, always label, upper Now for my mean, 26,250. My standard deviation, I'm going to plug in 1414. I'm going to go with the decimal too. Again, I just rounded for my drawing just so I can have a basis of reference here. And if you plug this in, you will get about 0.265. I'm going to double check that too. It's always a good idea to double check that. When possible, double check, because I did this in class. I'm going back in my calculator here, and I'll show you using the graphing calculator here. Okay, so second, distribution. Okay, not now. I'm going to go to norm CDF. Yeah, I'm going to go with that negative 99999, plenty of those. And I'm going up to 25,000. Got me of 26,250, and a standard deviation of 1414 point, I believe it was. Now I'm trying to go back. Bear with me. Got so many numbers going on here. 21. All right. Oh, okay. I'm glad I double checked that. So it got about 0.188. So believe it or not, that was really close to what I thought. Remember when I mentioned that, looking at that, it's about, maybe 16, low 20s. There you go. So that represents that 18%. Again, how they do this? We knew the mean number of pages. We knew a standard deviation. So what I did was I just figured out 50. Again, by just multiplying the mean of 1 by 50. Standard deviation. Just squared that standard deviation, added it 50 times, and then found that square root. Because again, you have to find the variance first. And then assumed a normal distribution to calculate that. Now for part B, what is the probability that at least 20 of the novels have fewer than 400 pages? Now, here's the thing. That 30%, you notice we didn't use that here in the first part of the problem. This is where you're going to be using it now. And this is going to be a binomial distribution now. Why is it going to be binomial? Because if you run through bins, it's binary, because either it has fewer than 400 pages or it doesn't. Independent, one book isn't going to affect the other. We have a set number of trials, which is those 50 books. And we also have a probability of success of 30. So here's how I would go about this. Now we have 50 books, so let's see. We're probability at least 20. So this is the way I always set it up. I go 0, 0, just below 20, just above, then all the way up to my total number of trials. I ask myself, which ones do I care about? Now it says at least 20, so that could be 21, 22, 23, so on. So I care about all of these. I want to find the probability of all those coming up. I don't need this. So here's what I could do. I could use the combination formula. Okay, 50, 20, probability of success is about 30. So that will represent 20 successes, 30 failures. And then I could add that to 21 successes, set it up the same way. I could keep doing this all the way up to 50 and just add them all up. That is a lot of work, and I don't recommend doing that. You can do it, but you don't have to. As a matter of fact, I would not recommend it. Here's what I would do instead. Instead of finding what I need, I can find out what I don't need right here, 0 to 19, and then just subtract that from 1. Why? Because this represents 100% of those possibilities. So if I find possibilities I don't need, that'll leave me with the possibilities I do need. And why am I going with the 0 to 19? Because that calculator function, binom CDF, remember, that calculates all your binomial probabilities, starting from, all right, it says 0, it always starts at 0, and then you tell it the highest number to stop at, and it adds them all up for you. So if you go binom CDF, total number of trials is 50. Notice I'm labeling. Always label, especially for that AP exam. Highest number of successes I'm looking at is, oh wait, I need the probability of success, 0.3. So prob of success. And then the highest number of successes, which I've determined is 19. Because again, I'm looking for at least 20. So I'm not going to calculate 20 to 50. I'm going to calculate 0 to 19, the ones I don't need. Which if you plug that in, I'll show you how you can do that. Go to second. Now I'm going to go to binom CDF. All right, 50 trials, 0.3. And the highest possible number is 19. and I get about 0.915. So I'm going to go here, right, 0.915. I'm ballparking it. So if this represents 0.915% of the outcomes, right here, then for these, all I got to do is subtract it from 1. 1 minus 0.915, and you get, I'm ballparking this here, I should probably use my calculator, but 0.085. So the probability that I get at least 20 is going to be about 8.5%. Again, I did that based on a binomial distribution. This problem was tricky because it asked you, basically, they gave you 2 sets of values to work with, but you're not using them all at once. So just remember that. Not just because they're giving them all to you doesn't mean you're going to be using all of them at once. So hopefully that helps you out with number 25. I know a lot of people had questions about this. So hopefully this helps you in the future when you see problems just like this.